Assalamualaikum and salam sejahtera to Professor. We from Group C want to explain about digital assignment. Our group member is Muhammad Al-Zahir bin Hamidi, Mogaraj, anak lelaki Krishnan Sami, Anwar Yang and Nur Ramadhani Afika binti Mionizam. My name is Nur Ramadhani Afika binti Mionizam. I want to explain about digital assignment part 1. Introduction. What is Verilog? Verilog is the hardware description language (HDL). It is a language used for describing a digital system like a network switch or a microprocessor or a memory or a flip-flop. By using a HDL, we can describe any digital hardware and any level. Designs which are described in HDL are independent of technology, very easy for designing and debugging, and are normally more useful than schematic, particularly for large circuit. In part 1, have two tasks. Task 1, design, simulate and verify a fully parallel 6-bit by 6-bit unsigned multiplier design circuit with 1-bit full adder and half adder as a building block. Task 2, design, simulate and verify a synchronous digital system that detects recognized student ID as password that can be used to generate an output signal. Okay, for task 1, this is a block diagram. We use 2 input and 1 output. In input, we declare A and B for input and P for output. At input, we use 6-bit for A, 6-bit for B, and the output have 12-bit. Next, this is a circuit for half-adder circuit and full-adder circuit. We combine 2 half-adder circuit to produce 1 half-adder circuit. In half-adder circuit, we declare A and B for input, sum and carry out for output. For full-adder circuit, we use A, B and carry in for input, sum and carry out for the output. Okay, this is a calculation before we do the coding and simulation. As we know, we declare A and B for input and P for output. We use 6-bit for A and 6-bit for B and produce 12-bit for output. Firstly, we must to multiply A and B to get the output P. Okay, first we multiply B0 times A0 to get output PO, B1 times A0 to get the P1 output, B0 times A1 to get the output P1, B2 times A0 to get the output P2, B1 times A1 to get output P2, B0 times A2 to get the P2. Okay, B3 times A0 to get the output P3, B2 times A1 to get the output P3, B1 times A2 to get the P3, B0 times A3 to get the P3. For B4 times A0 to get the output P4, B3 times A1 to get the P4, B2 times A2 to get the P4 output, B1 times A3 to get the P4 output, B0 times A4 to get the P4 output, B5 times A0 to get the P5 output, B4 times A1 to get the P5 output, B3 times A2 to get the P5 output, B1 times A4 to get the P5 output, B0 times A5 to get the P5 output. Next, B5 times A1 to get the P6 output, B4 times A2 to get the P6 output, B3 times A3 to get the PC output, B2 times A4 to get the PC output, then B1 times A5 to get the PC output. Next, B5 times A2 to get the P7 output, B4 times A3 to get the P7 output, B3 times A4 to get the P7 output, B2 times A5 to get the P7 output, B5 times A3 to get the P8 output, B4 times A4 to get the P8 output, B3 times A5 to get the P8 output, B5 to B5 times A4 to get the P9 output, B4 times A5 to get the P9 output, B5 times A5 to get the P10 output, and so on.
Okay, thank you Fika for the explanation. Okay, my name is Ahmad Zahir bin Hamidi and I would like to explain about circuit diagram for multiplier 6 by 6. Okay, as previously known, there is two input which is A and B. A0, A1, A2, A3, A4 and A5. B0, B1, B2, B3, B4 and B5. As previous, we can see A0 multiplied by B0, we get A0 and B0 and the output is P0. So to do the circuit diagram, we can see here A0 multiplied by B0, which is we're using AND gate, and the output is P0. Okay, for the next circuit, we are using B1, A0 and B1, A1 and B0. So we're going to use for B1 and A0, B0 and A1. And we combine these two using half adder. And the output is P1. The half adder, which is has carry, the carry will go into the full adder one. Okay, next, we get B2, A0, B1, A1, B0, A2. Okay, B2 AND gate A0. B1, A1, AND gate and combine to become full adder, because full adder is used because there is more than two input. We got here B2 from AND gate, B2 and A0, B1 and A1 and half adder carry. We're going to use full adder, and we're going to continue to the third input, which is B0 and A2, because there is 3 B2, A0, B1, A1 and B0, A2. So we're going to use half adder because there is two input, B0 and A0 and full adder. So the output is P2, and the next is going to be the same. From Azari, and I would like to show you guys how to use ISE Design Suite version 15.5. Firstly, you need to have the apps. Open the app. Okay, firstly you need to create new project. The project you can name everything you want. For example, I name it project. You need to make sure that the synthesis tool is HDL Verilog and simulator is HDL/Verilog. Preferred language is Verilog. Finish. Okay, then we need to create new source, which is where we're gonna write our coding. Because we are learning about Verilog module, we are going to use Verilog and rename such as, for example, full adder. There is an option so we can put our input or output here, but we can skip this and we can put it later in the coding, and click finish. So we got this space where we can create our coding. Okay, that's all. That's how you use ISA project navigator to run Verilog module. Okay, next I'm going to explain about the coding for the multiplier. Okay, for the multiplier, we have 4 separate coding, which is the first is for the multiplier module, and the second one is for half adder, the third one is for full adder, and for the test bench. Okay, for the multiplier, we need to construct the coding based on the circuit diagram. Okay, first we need to define the input and output, which is A, B, and P. Okay, for the input, which is 6-bit A, the second input is 6-bit B, and the output is 12-bit P. Okay, and then there is wire. Wire is for the connection between the full adder, half adder, and the carry. And there is for the first circuit, which is N1, AND gate. Based on circuit before, we using AND gate for A and B, and P is for the output. For this kind of coding type, which is circuit, which is this coding type, we need to put input first, which is P0, and gate for the A0 and B0. And this is for the first circuit. The second circuit, there is 2 AND gate and 1 half adder. For the AND gate, there is Y1 for the connection to the half adder, A1 and B0. The second one is AND gate, Y2, A0 and B1. And for the half adder, there is P1 for the output, Y1 for the AND gate N2, Y2 for AND gate N3, and Y3 is for the carry. And the next coding is going to be the same as the previous concept, which is the output is first and the wire is connect to the full adder and the half adder. Okay, the next is for half adder. We need to define the coding for it half adder. So the half adder consists sum, C out, A and B. The input is A and B and output is sum and C out. The half adder is consists of 2 gate, which is XOR and AND gate. And there is the sum is output and C out is for the output. And the full adder, there is input A, B, and C in, output sum, C out, wire N1, N2, N3, and N4. Same as previous, N1 is for the wire which connect to the A and B for the XOR gate. Sum N1 and C in. Sum is for the output. N1 is for the wire to the XOR, and C in for the input, and so on. So after we finish constructing all this coding, we need the test bench we need to input the bit value for testing on the simulation. Okay, the test bench is we create 4 cycle for each multiplier. For the first one is B 10000 and 00001. Second one is B 10 1010 010101 1111 000, and the last one is B1 10011 B001100. For the this is for the each cycle, how long it's going to take for the each cycle. The 6 is refer to the 6 bit, and B for the hexadecimal. Okay, so we need to run the behavior check syntax to make sure all the coding is right. Okay, as you can see, the syntax is complete successfully, and we need to run behavioral model for the simulation. Okay, as you can see here, there is 4 cycles. As you can see on the first cycle, 10000 and 0001, the output is 0001 0000. Here you can see the output. And for the next, we can see the output for the multiplier 6 by 6. This, and this. And next, the third cycle, and for the fourth cycle. Okay, that's all for the multiplier. I would like to call Mugen for the next presentation.
Thank you, Zaya and Afika, for allowing me to answer the second task. Hi, I am Morgan Raj. I will present my presentation to your questions. In this task, we use mode counter as a synchronous digital system. Here, now we see the coding for task 2. We name this module as counter and we used one of our group members' metric number for testing. As a start, in bracket we can see clock, enter, reset, count, access, alarm are input and outputs. Parameter n equals 4, which let us know the three wrong attempts make alarm to turn on. From here, we can see clock, reset, enter are input and access, alarm other three are outputs. Passage is the event of changing a value of either a variable or net with direction towards the value in Verilog. I would like to convey an important message. Whenever reset button been pushed, we set everything to default value. At here, when alarm is set to equals to be 0 and also the count is set to equals to 0. In case if new wrong password entered, key is equal to 0 and enable equal to 1 while the count of previous cycle was 2. Alarm is turned on and access is denied. So here we use if else statement to progress the coding to get the result. If it's not happen regarding the statement, this else statement will be enabled which make count equal to 0. The access will be high at the moment. Next coding is renamed as main part 1, which is considered as main module for this task. Here we can see the reset, set pass, pass in, enter as input, the access count alarm as output. We reset and enter button work like the reset and enter button of password based logs log system. From line 40 to 44, where I declare input, output and wire codings. We added check as wire, add check assign, x equal exclamation mark, in bracket set pass upper arrow, pass in. In the wire check, we put the comparison value, set pass and passing, and feed into the modern counter or the previous counter module. Combine this main part module and counter module on the code we create. This is the circuit which have been generated based on the code we create. When the combination module combined with password log module, the code resemble as Intel data in the circuit. This is the input data which recognized we entered the correct data or not. To get waveform for this task, let's see next code, which is known as Systembenc. In order to get the output of the timeline, we have to declare input either is low or high. You also must do customization of coding to make it work each and every input. The inputs are set beside the REG and the outputs are set beside wire. This is the main code for our test bench which plays main lead to get waveform. Just assume we are entering the wrong pass at first cycle and also in second cycle, then we enter the correct pass at third cycle. Then assume back again by entering the wrong pass at fifth cycle and also at sixth cycle. Then enter back again in the correct pass at seventh cycle. Before end the module, add check assign equals exclamation mark in brackets set pass pass in. Now I will forward to Ang Wei Yang and he will present the output of waveform from the text bench code.
So thank you, Morgan. I'm Ang. Now I will explain about the output waveform for task 2. Here we can see there are some important line we need to focus: the check line, the alarm line, and the pass-in line. So for task 2, we need to key in the student ID as our password. So when for the pass-in line, we can see that there are a lot of different set binary numbers. This is because when we key in the password, the system will change the password into binary form. For example, when we key in B022110010, the system will change it become the binary form. So for checking line, we can see that when we key in the correct password, it is 0 B022110010, the chat line will become 1 is, or we say that it will become high. After that, it will be reset. So what if we key in the wrong password? So when we key in the wrong password, like B022110035, it will be remain in low, or we can see that it is remain constant. So after that, we also can see that when we key in the wrong answer for 3 times in a row, the alarm will be triggered. So for the alarm line, it will become 1. Okay. So for the conclusion, we can knew it that Selenium software is suitable for beginners who trying to make coding, especially for Verilog or VL, VHDL as the first programming language. So we also can see that we can complete this project by doing simulation, verification, and set up a moderate complexity digital system very well. So for implementing the idea through the guideline and the note given by our lecturer in class is important, because to know the outcome and the project before getting deep into the project. So this project give a good impact for students to report writing and presentation. End of the learning outcome, we learn to create coding and able to complete a project by ourselves with. Thank you.